Good morning. So dear student, you have learned that a chemical equation should be balanced in accordance to the law of conservation of mass, which states that in a chemical reaction matter is neither created nor destroyed. So in a chemical equation, the number of atoms of various elements on the left hand side, that is the reactant side, and on the right hand side, that is the product side, should be equal. A chemical equation in which number of atoms of various elements on the left hand side and right hand side are not equal is called a skeletal or a unbalanced chemical equation. For example, in this equation you can see on the left hand side we have one atom of magnesium and two atoms of oxygen to form magnesium oxide, which contains one atom of magnesium and one atom of oxygen. Obviously, there is a loss of one atom of oxygen. So it is not balanced chemical equation and it is said to be a skeletal chemical equation. So remember, whenever you write a chemical equation to represent a chemical reaction, balance the chemical equation. For example, this equation now contains equal number of atoms of magnesium and oxygen on the left hand side and on the right hand side. Such a chemical equation is said to be a balanced chemical equation. Today we shall learn how to balance a chemical equation. Remember, there is no a clear-cut method or a formula to balance a chemical equation. We use hit and trial method. More you practice balancing the chemical equation, more you become expert in balancing chemical equation. So it is the practice which will make you perfect in this regard. However, we shall try to follow a definite method to balance a chemical equation. Consider this chemical reaction. Iron reacts with steam to form magnetic oxide of iron and liberate hydrogen gas. You can see that this equation is unbalanced as it contains unequal number of atoms on left hand side and right hand side. So we shall balance this chemical equation. In the first step, you write down the number of various atoms on the left hand side and right hand side separately. For example, on the left hand side, number of iron atom is 1, hydrogen is 2, that of oxygen is 1. And on the right hand side, we have 3 atoms of iron, 2 atoms of hydrogen 4 atoms of oxygen. Obviously, it is not a balanced chemical equation. So, this is the first step. Now, in the second step, you enclose the reactant and the products in boxes. In the third step, you choose the chemical species on the left hand side and on the right hand side which contain maximum number of atoms, and on the basis of this criterion we select Fe3O4 which contain 3 and 4, 7 atoms, and in that compound we shall select the element which contain maximum number of atoms, and on the basis of this criterion we select oxygen. That is, we shall starting balancing the number of atoms which are present in largest number. Now on the right hand side we have 4 atoms of oxygen, and on the right hand side we have only 1 atom of oxygen. So a coefficient 4 will make the number of oxygen atom on both sides equal. After this, we shall select the element which contain maximum number of atom, and we select iron which contain 3 atoms. Now on the right hand side we have 3 atoms of iron, whereas we have only 1 atom of iron. So we put a coefficient 3 to make the number of iron atoms equal. Now the third element which is left is hydrogen, and you can see we have now 8 atoms of hydrogen on the 4 into 2, 8 atoms of hydrogen on the left hand side, and there are only 2 atoms of hydrogen on the right hand side. So we put a coefficient 4 so to make the number of hydrogen atom equal. Now see whether the chemical equation is balanced. It contains 3 atoms on the left hand side, 3 atoms on the right hand side. 8 atoms of hydrogen on the left hand side, 8 atoms of the hydrogen on the right hand side. We have 4 atoms of oxygen, we have 4 atoms. Now this equation is balanced. Now rewrite the chemical equation by removing the boxes. So this is our balanced chemical equation. So this is how you can balance chemical equation. Dear student, according to law of conservation of mass, in a chemical reaction matter is neither created nor destroyed. Then what happens in a chemical reaction? In a chemical reaction, rearrangement of atoms takes place, and this rearrangement of the atoms result in the formation of new compounds. See, for example, when magnesium burns in air, it combines with oxygen to form magnesium oxide. In oxygen, two atoms of oxygen are bonded together by a double covalent bond. So first of all, what happens? This chemical bond, old chemical bond is broken and oxygen atoms become free. After that, these oxygen atoms combine with magnesium to form magnesium oxide, which contain magnesium ions and oxide ion. So covalent bond is broken and a new ionic bond is formed between magnesium and oxygen atom. So you can see that in a chemical reaction, rearrangement of atoms takes place. Old chemical bonds are broken and new chemical bonds are formed. This rearrangement of atoms can take place in a number of ways. Accordingly, we have different types of chemical reactions which involve different mechanism and different arrangement of atoms. Today we shall try to describe a few types of chemical reaction. Let's see. Consider there are two reactants A and B. These two reactants react together and form a product AB. So what you see here, in this reaction, two reactant, the reactant may be more, two or more reactant combine together and form a single product. For example, in this reaction you can see magnesium and oxygen, which are the reactants, and magnesium oxide, which is a product. There is only one product and two reactants. Such a chemical reaction in which two or more reactants are combined together to form a single atom are called combination reaction. Let's see few examples to understand. Quicklime, calcium oxide. It is also known as quicklime. When quicklime is added to water, a vigorous reaction occurs with hissing sound and calcium hydroxide or slaked lime is formed. Quicklime or calcium oxide reacts with water and form slaked lime and liberate heat, which is responsible for hissing sound. The hissing sound is produced due to the evolution of large amount of heat. So in this reaction you can see that two reactants are combining together to form a single product. When carbon dioxide is passed through washing soda, this is sodium carbonate or washing soda, and carbon dioxide is passed through the solution. Sodium hydrogen carbonate or sodium bicarbonate is formed. You can see that in this reaction, three reactants are combining together to form a single product. So such reaction in which two or more reactants, two or more simple substances are combined together to form a single product are called combination reaction. Decomposition reaction. Decompose, broken down. When ferrous sulfate crystals, which are pale green in color, ferrous sulfate heptahydrate when ferrous sulfate crystals are heated, they lose water of crystallization and turn anhydrous ferrous sulfate. This anhydrous ferrous sulfate is colorless. So first observation that you will observe when ferrous sulfate crystals are heated is that the ferrous sulfate crystals become colorless on heating. On further heating, ferrous sulfate decomposes into iron third oxide, sulfur dioxide and sulfur trioxide. It is reddish brown in color. And sulfur dioxide is a colorless gas which possesses the odor of smell of burning sulfur. So what you observe when ferrous sulfate crystals are heated, first they turn colorless, and then a colorless gas is evolved which possesses the smell of burning sulfur. On obviously in this reaction you can see that ferrous sulfate on strong heating decomposes into ferric oxide or iron third oxide, sulfur dioxide, sulfur trioxide. So it is a decomposition reaction. Similarly, when lead nitrate crystals, they are solid colorless crystals. When they are heated, lead nitrate decomposes into lead monoxide, nitrogen dioxide and oxygen. This nitrogen dioxide is brown in color. So since in this reaction lead nitrate on heating decomposes into lead monoxide, nitrogen dioxide and oxygen, this is an example of decomposition reaction. So remember, when lead nitrate is heated, a brown color gas is evolved. And what is this brown color? This brown color is actually nitrogen dioxide, NO2. Dear student, a decomposition reaction requires energy to decompose a compound into two or more simple substances. This energy can be supplied in the form of heat or light or electricity. Hence, we can classify decomposition reactions into three categories on the basis of energy required by the chemical reaction. Number one, the decomposition reaction which require heat. Such decomposition reactions are called thermal decomposition. When a compound is broken down into two or more simple substances, when electric current is passed through it, the reaction is called electrolysis. And photodecomposition reaction, when a compound is broken down in the presence of light. So in the next video we shall discuss various types of decomposition reaction. Thank you.